Okay, this problem gives us a chart and a graph and says that f is defined by a formula, cosine of 2x plus e to the sine x. G is a differentiable function, and g and g prime are shown up here. And then h is a graph that is provided. So we're essentially doing derivatives and work with formulas, tables, charts, and graphs. Tables, charts, and graphs. Okay, part A. Part A is find the slope of the line tangent to the graph of f. So we're going to work with the formula first. Our first goal is the formula. A, so f of x is equal to cosine 2x plus e to the sine x. So the slope of the tangent line is going to be the derivative, so we need to find f prime of x first. The derivative of cosine is negative sine of 2x. But then since this was not just an x, we have to perform a chain rule, and the derivative of 2x is 2, plus the derivative of e to the something is e to the something, and then that needs to be multiplied by its chain rule, which would be the derivative of sine x, which is a cosine of x. So that's our derivative. They want f prime at pi. So f prime of pi would be negative 2 times sine of 2 pi plus cosine of pi e to the sine of pi. Okay, remember sine of 2 pi is 0, and cosine of pi is negative 1, and sine of pi is 0. So we end up getting, as our final answer, 0 plus negative 1 times e to the 0, and e to the 0, of course, is just negative, or sorry, e to the 0 is 1, so negative 1 times 1 is just going to give us negative 1. Looks like the final answer to the first part is negative 1. Okay, part B. Now we have a k function, which is defined in terms of h and of f. So in part B, k of x is equal to h of f of x, and they still want something to do with the derivative. So k prime of x is going to be h prime of f of x times f prime of x. Right, that's the chain rule being applied to that thing. So if we want to do k prime of pi, we're going to need h prime of f of pi times f prime of pi. So let's go figure out what that is. So h prime of f of pi, I'm going to do this part first. F prime of pi I already did in part A. That's negative 1, so I'm going to insert the negative 1 here. But I do need to go figure out what f of pi is. So in order to find f of pi, I'm going to go back up here and recognize that f of pi is going to be cosine of 2 pi plus e to the sine of pi, e to the sine of pi. Cosine of 2 pi would be 1, and sine of pi is 0, so this becomes e to the 0, and e to the 0 is also 1. So it looks like we're getting a 2. So getting h prime of 2, negative 1. Remember, that was the 2 coming from the f of pi that I had to do separately. Ooh, h prime of 2 means now, though, I have to go up to the h. Here's my h graph. At 2 is located right here. H prime of 2 would be the slope of the curve, right? In this case, the line. So if I look closely at that line, I can see that it has a slope of 1 over 3, and it's negative, so its slope is negative 1/3. So when I come back down to here, I'm going to say h prime of 2 is negative 1/3. That came from the graph, multiplied by negative 1, and so it appears that the final answer comes out to be 1/3, and that completes part B. See, I like these. These are like puzzles. Part C. M is now a completely different function. M is defined to be this function, and they want us to find m prime of 2. So I'm going to do m prime of x. M prime of x, this is g times h, so this one's going to be a product rule. So I'll do first times by the derivative of the second plus the second multiplied by the derivative of the first. And I'm not going to forget my chain rule when I take the derivative of negative 2x. So that's m prime of x. M prime of 2 is going to be g of negative 4, because negative 2 times 2 is negative 4. H prime of 2 plus h of 2 g prime of negative 4, negative 2 times 2 again, and then multiplied by a negative 2. Yeah, okay. Chart. G of negative 4 is 5, and g prime of negative 4 is negative 1. So all I did was insert the g prime of negative 4 is negative 1, the g of negative 4 is 5, and then carry down the negative 2. Now h is the table, so we're going to use the table for this one. H prime of 2 means I got to go to the number 2, and notice that my h is still that same line, so that's a slope of 1/3 in a negative direction, so this is negative 1/3. And the h of 2 means I actually need to know what the output is at 2. So since it's going from 0 to negative 1 and its slope is 1/3, that means that's negative 1/3, that's negative 2/3, that's negative 3/3. So at 2, the value is just going to be a negative 2/3. Negative 2/3. So now it's just some arithmetic, right? This is negative 5/3. 2 times 2 is 4, so we're getting a 4/3. Negative, negative, negative means it's a subtraction. And we're getting negative 5/3 negative 5/3 plus negative 4/3. So I'm thinking I'm getting a negative 9/3 here, and that's a value of negative 3. So I think the value we're going to get out of this one is a nice old negative 3. Ended up being pretty convenient. Okay, ready for the last part? The last part is a justification. Is there a number c in the closed interval from negative 5 to negative 3 where g prime of c equals negative 4? Okay, so notice that g is a differentiable function. It said that g is a differentiable function. So that means g is differentiable and thus continuous, and so the mean value theorem holds. So that's what we usually work with when we're dealing with finding something true about the derivative of g. It's usually going to be a mean value theorem. And so on the closed interval from negative 5 to negative 3, the mean value theorem is going to say, so there is a c between negative 5 and negative 3 with g prime of c equaling essentially g of negative 3 minus g of negative 5 over negative 3 minus negative 5. F of b minus the difference quotient, right? F of b minus f of a over b minus a, or the a rock I call it in my class. Okay, what is g of negative 3 and g of negative 5? Well, g of negative 3 is 2, g of negative 5 is 10, and that's over negative 3 minus negative 5, so that's negative 3 plus 5, which is 2, and then 2 minus 10 is negative 8 over 2, and so that's equal to negative 4. So if I go back to the problem, is there a number c in the closed interval for where negative on the closed interval negative 5 to negative 3 where g prime of c equals negative 4? The answer is yup. Justification is by the mean value theorem.